Hi everyone. I'm looking forward to seeing your letters of intent and lining up your team with a project that suits your interests and capabilities. Today, I'd like to talk a bit more about describing the design specification and about working with your client. When describing the design solution, it's most important to keep in mind not what it is, but what it does. It's easy to get caught in a design trap of preconceiving what the solution is, thereby canceling out all of the possible alternatives that may be better solutions. Henry Ford, who is the inventor of the modern mass-produced automobile, liked to say that if I had asked people what they wanted, they would have said faster horses. That is the problem when you're talking to a client and asking what they want when they have a preconception about what the solution will be. Here's a simple example. Let's say your client is a chef who wants a way to get dishes cleaned. If the chef comes to you and says, I want a pair of robot arms that can wash the dishes in my kitchen sink, then that constrains the possible solutions. Instead, your team should ask what the client really needs, which is dishes that have food and grease removed, are cleaned to a hygienic standard with no cleaning residue, and have a pleasant smell without overpowering food aromas. An alternative solution is a washing machine, right? That magic box into which dirty dishes are placed and a spray of water automatically applies soap and then rinses with enough force to clean and rinse, which achieves the same result. Another legitimate solution may be to hire someone to wash the dishes. If the chef really wants a high-tech kinetic sculpture in the kitchen that looks like it's doing dishes as an amusement for the restaurant patrons, then that is a completely different problem. In that case, a pair of arms that moves like a person would wash dishes becomes a reasonable concept. But in that case, the cleanliness of the plates is not actually a high priority specification. The specification should be SMART, S-M-A-R-T. That is simple, measurable, achievable by your team, reasonable, and can be done in the time available. Each specification should be described as quantitatively as possible, in a way that can be measured. In this way, there's no argument with the client later on whether the spec has been achieved or not. A qualitative spec is liable to be challenged, as in, the outer shell should be aesthetically pleasing. Some specs are best expressed not as a single number but as a range. For example, shall have a mass less than 5 kilograms, or should be able to achieve a top speed on flat ground with no wind of at least 10 meters per second and not more than 14 meters per second. Some specs will have conditions associated with them, such as shall not have an interior temperature above 35 degrees Celsius after 1 hour of full sunlight. A subjective criterion can still be measurable. Now, the odor of those clean dishes is detectable, and people can be trained to assess odor intensity and type, even though there's no such thing as an odor meter that has a range of 1 to 10. Many performance and durability specifications can be tested using standard methods. For example, the wear resistance of a material can be tested using various abrasive wear techniques that are published by standards organizations. So your specification may refer to a code or a standard. Some specifications will be much more important to the client than others. An enclosure for an embedded vehicle tracking system must allow GPS radio signals to reach the antenna. Being leak-proof may not be as important as being able to operate at a wide range of temperatures. The radio reception is a must. There will be a required temperature range that it has to work in, and then a broader range in which the client would like it to work. And a leak-proof enclosure is just a nice to have. So the specification matrix will have weightings to show the importance of how these features are ranked. The musts, the high wants, and the nice to haves. The spec can be organized by function or by physical systems. It's up to you, as long as the organization of the structure makes sense. There's a number of ways to describe technical and functional specifications to reflect the client need, which are sometimes referred to as the voice of the customer. Quality function deployment, or QFD, is a well-known structured approach to defining customer requirements and putting them into a product development plan. The easy approach to requirement syntax, or EARS method, has a standard process for describing clearly what the design will do and not do under different circumstances. When you're working with the client, it's important to seek to understand what the client actually needs. Asking open-ended questions allows the client to describe the problem and the motivation for the solution. Guided questions by your team then allow the client to clarify what the solution needs to do, as opposed to what features it would be nice for the solution to have or how it should look. Unless aesthetics are a key part of what the client requires. When your team interacts with the client, it should be on the client's term to show respect for the client and the client's time. Other ways to show respect are to show up for meetings on time, to have a respectful discussion, to gather information, and to follow up with the client so that the understanding is clearly interpreted. It's not the client's job to brainstorm what the solution will be. That's why the client has engaged you as the design team. The client can offer suggestions, but don't be constrained by the client's opinion. That's why it's so critical to understand what the client's needs are so that your team can then explore the design space of possible solutions, guided by the boundaries of what the solution must do, should do, and must not do. Later in the project, there's going to be a realization that some specifications are going to be in fundamental conflict with each other. It's not generally possible to have a high-quality design with a lot of features that is also super cheap, safe, and sustainable. If there's a bust between competing specifications, then your team will need to put together an evidence-based argument to show the client how the specs are not both achievable, with a recommendation of what to do. That is, what specifications have to be modified. It's important to go to the client with an issue and the proposed resolution. Go to the client with a solution, not a new problem. By helping the client to define their real need, and by turning that into a clear set of specifications, your team will be ready to plan the project and then move on to creating ideas of what that solution might look like. But first, we have to make a plan, and that's what we'll discuss next.